So far, all we have done is we have started the entire class, basically a quick review of what maybe you should have known and, ex- and advanced a little bit to where we are today. We started the whole class talking, reviewing your load diagrams, and then we moved into the stresses that you probably know. And from there, we found the design point. I want to give you an overview of where we at and where we are headed the next couple of weeks, or maybe the entire course. So uh, basically, all we have done is we have covered the beam analysis. Um, we went over plane area properties. That will be the cross-sectional area that's used for the axial load, the effective area used for your shear load, your uh, bending sectional modulus, uh, section constant, uh, and then you have your torsion uh, parameter. These are all functions of your cross section. So if I drew the cross section, right, if it's a circle, maybe a cross section can be square as well. So they're all functions of the cross section, and the various probably come from tables I gave you. We also did the load diagram, the load analysis. In the load analysis, we identified the critical location in the beam. So we found what was this, what was uh, X critical. We also went to stresses. Using this information, we calculated the state of stress. From the state of stress, we identified your design point. That was your topic number 2. And we also found what your state of strain was. And we related the state of strain to state of stress. We went one way and the other, and it's possible to do that, right? Also, using these properties, I showed you that I could go from load analysis to my internal load analysis, internal loads to my internal stresses and internal strains. Now, from here, I can also calculate deflection and rotations, but I am not covering that in this part of the course. And these are all the topics that you have to know for for your next test. So your test 1 is going to cover everything for your 2 homeworks and everything on this page. Let's go to the next slide. So this is where we are headed. What was the purpose and the goal of everything we do? Let's not lose sight of what we are doing. In the case of maybe I am designing a stapler, maybe I'm designing a plane, whatever I'm doing, I'm trying to find the critical location. Well, what was the goal of that? What was the goal of finding the critical location here? What was my end goal of this? My end goal was to find a location where we'll have maximum stresses, make sure that point will be completely safe. We don't want that to fail, right? So that was one of the main goals of everything we do. So to move on for that, we want to design everything safe. We want to design safe structures against stability. Stability is nothing else like is buckling of perfect columns and imperfect columns. This is going to be topic number 3. And this is mainly what we're going to cover is a static phenomena. Okay, is only for static. You can also have stability, dynamic stability, but that's beyond the scope of this course. We also going to do strength check. For strength check, we will do linear fracture mechanics. Linear fracture mechanics. And for static, then we're going to do many different cases. I'm going to expand on this. I'm going to expand on this particular part in the next slide. And that's going to be the topics for test number 2. Now, then we would talk about fatigue, and also that's going to be probably the topic for test number 3. So let's move on to the next part that we're going to do in the course. So first we understand everything static. We want to do buckling analysis in a nutshell. And then we're going to do fracture and static. So done buckling in strength, this is topic number 4, that's fracture. Topic number 5 is going to be static failure due to static loading. In the static loading, we're going to talk about ductile materials and brittle materials. In ductile materials, we're going to have 3 different cases. For brittle materials, we're going to have 3 different, 3 different theories, and here we have 3 different theories. And we're going to learn when to use one, when to use the other. These can only be used for ductile, and these can only be used for brittle. The same thing for fatigue. Fatigue, we're going to analyze everything for ductile materials and brittle materials, and that's going to be topic number 6, and that's going to be half of your test number 3. Okay, and then we're going to do springs. In springs, we're going to do static, and we will do fatigue. It's mainly the application of most of this fatigue theory that we learned here. So with that said, we will do, that's going to be half of the topic, half of your test number 3. The last topic for test number 4 is screws and fasteners. We will do that again for static, and we're going to do that for fatigue. Every analysis has to be done for static, and fatigue. Many times, one of the biggest mistakes that engineers do is they say, well, let's study everything and design something for fatigue, and we say for fatigue, we stay for static. It's not quite correct, because think about this. I got this pen, right? And I'm constantly applying load. Now, the load is not completely applied constantly over a long period of time. It just goes there, but then I keep moving. So now this is more an oscillation problem than is a constant applied problem. There are cases in which you might see that this pencil might fail in static before it fails in fatigue. And or vice versa, that can also happen. So you have to check always for both. That's why you see that for all the problems I'm suggesting, we will do static, we do fatigue. We do static, we do fatigue. We do static in strength, and we do fatigue in strength. This is where the money is. And then we're going to end up the very last topic in the course. We will do shaft analysis all the way throughout the course as we go. However, this is covered there, but if you're missing something, we will cover it here. And keys and belts is topic number 9. If we get a chance, we will cover that, and that will be included in your final test. So in a nutshell, this kind of summarizes this summarizes what we really have done and where we're headed next.